Right, well, today we've got a Harvard which seems to have come apart during transit, even though it was well packed. But we know what these things are like with transit. So, this is a purchase off eBay from one of our regular customers, and he's paid £25 for it. And before we all our eyes pop out, it's reputed to have got an intact aerial, so that's worth 10. Because that's how much they were at the time, and they're irreplaceable now. So, aerial aside, you're paying 15 quid for the rest of it as far as I'm concerned. It's got a back. I've matched the serial number up to this eBay purchase, and I've scribbled out the purchaser and the user because we're not talking about either of them. So it's sold as parts for repair. The radio transmits okay, but no receive, just a crackle. So it's sold as to be repaired. The case is in very good condition and no returns owing to the nature of the hobby, which is fine. And then I looked at the photos on the computer and all angles have been shown. And one of the things that surprised me, one of the things that made me go towards that is why, let's get the light on that, why has it got a hole in the side? And it is there on the photos, but you know, unless you were looking for it, you know, it probably doesn't matter an iota, but I don't know. And this gentleman seems to sell quite a lot of CB related stuff, and I have bid on stuff in the past, and I don't take any notice of whatever, you know. It no doubt did what it said on the tin. And he says it's got a good condition battery compartment, which it has. I suspect it's been used a lot on its external power supply, if it's been used at all. So the reason it fell apart in transit is there's no screw in there. So I don't know whether we can rectify that. But that's in excellent condition, which makes a change. So I better put my smouldering bat on. Now you can't. This is kind of dirty and sticky, like it's lived in a chip shop. When we when we were in TV repair, I can't speak, repair business, we had a customer with a chip shop and a television, and you can imagine how greasy that was. We had another customer, and she was a dressmaker, and these were all black and white tellies I'm telling you about, but she managed to drop a whole pile of pins down the back of this television. So we were there with a bit of a magnet pulling all these pins out from amongst the dust. Anyway, kind of happy memories in a way. Bring back black and white CRT TVs. That's my thing. Well, I stopped having a TV in 2020 when it went digital. I'm in a rubbish reception area. We put a set-top box on. Could get 3 channels which were of no interest, like jewellery auction channel and rubbish like that. And that was the end of that. So that's £150 a year. I don't have to fritter away on a TV licence because we don't have any TV capability here. So, what they've gone and done, they've put high-low power to the side when it's in the back. So, you know, yeah, that's been nice, kind of nicely done, but it's come unscrewed, hasn't it, or unglued, or however it was done. So we'll restore it back to where it's supposed to be. That's the best option. But I've never seen that done before. Right. Well, we better unsolder the aerial and the battery connections and all that. And that aerial connection isn't tight. If I can even unsolder it at all. It's waggling round. So, this is going to be fun, isn't it? Because we've got to take the bottom board out. the only board out. The muter has gone askew in the transit, so I got to do this anyway. That first screw's going round and doing nothing, so that doesn't surprise me. So the expensive transistor, the output transistor on these, it is MPS U331, and it can be difficult to get. Hang on a minute. Has somebody put an earphone socket on it? That's a it's a good idea, that. Yeah, I think somebody's put an earphone socket on that. That's what that's about. Because you've got the external power. You shouldn't have a socket there. I mean, had that all screwed in nicely, then that would have been fine, but it doesn't, so it's got to go back. So, to get the chassis out, I'm going to have to release... Could do that thing from Monty Python's Life of Brian, couldn't I? Release Wadwick. Because he's a wobber. We'll pop out the power input socket, and then your external air release on the top. I always refer to these sets as fragile, because they are. Now what? Oh, there's a screw behind that socket. That's why I've missed it. Do you know what? I don't think I've ever had a dry joint on one of these, so I bet you that this will be the first one with a dry joint. I'll tell you what I'm tempted to do. It's not my radio. But I'll tell you what, I'm going to put the cases through our dishwasher. And if it all melts, well, I'll have to give him another working set, won't I? It's so nasty and sticky. I think it's worth it. Now, how's that loudspeaker sat in there? I bet it's just glued. So I'll take the aerial socket off the top as well. I wish I had a pin driver to do these. I've never seen one offered for sale. So that's the top off. We've already got the bottom off. I'll remove the telescopic aerial. And put that to one side. So that's two things prepared for the dishwasher. What we then do is dry it in an air-conditioned room so the moisture soon gets sucked out. We always do that with our valve radio stuff. That's good fun. I think we'll no, I don't want to unsolder that. We ought to unsolder it, but it's just an impact adhesive that the speaker's in with, but it's still jolly good after all these years. it's coming. And so it's Christmas, everybody says. There we are, done it. I've never even seen one of those before, so it's a plastic cone. That makes it kind of waterproof. So I'm going to take these case bits and I'm going to put them in the company dishwasher. Okay, so about 3 hours later, I've taken Mr. Chippy successfully to have his second COVID jab at Lincoln. And also calling in at the garage on the way back, where my Toyota Corolla, which is about 24 years old, is currently having its MOT. And you know what? It needs a tyre. Well, so meanwhile the dishwasher's been dishwashing, and I can actually put these two knobs back. I'm just drying the bits and pieces in the air-conditioned back room. Talking of air conditioning, we've got it on in here, as you can tell. So I need to put these knobs on in the right order. It looks like the red one's that one. So we'll set about doing this now. I don't remember that kind of filter in this kind of set. I really don't. Anyway, we'd better take this out. Put the soldering iron on. Still got some of this stickiness, whatever it is, on the display. I'll clean that off, of course, before we put it back together. So beautifully done on screen cable. Make sure these are flat. Don't want to wreck the holes. There's only solder on two surfaces, so it must go in that way round. You know, it's not the same switch, it's a different switch. We'll have to find a scrap chassis, and I know we have. I know we've got one of these. So here's a scrap chassis, which I bought for a couple of quid some years ago from a radio rally. which have been messed about with big time. You know, they have changed that filter, haven't they? Put the filter, they put a posher filter there. This is all worrying because there's no receive on this, but anyway, we'll do this switch first. Now, of course, we've got no proof that this ever worked on receive after it was being modified, so we may end up modifying it back to standard to try and get some kind of possibility of the thing working. I mean, you shouldn't be using this kind of radio as a base station anyway, and we know they're abysmal receivers, and that's going to help with bleed over, but it's not going to help with the rest of it. So, let's see, we've got power on. So I'll switch on picture in picture. I will when I get there. Right, I've now switched on picture in picture, and it's showing on my monitor. So press transmit. No, we won't. We'll switch it on. Yeah, we have switched it on. That's transmit. So are we in low power? Yes, we were in low power. So I think there's a 2.5 watt radio and it's doing 2.5 watts. So it doesn't get much better than that. I'll dig the circuit diagrams out in a minute when I've seen where we are with the receiver. So I'll put the signal generator on. Channel 9? Well, no wonder I'm not getting anything. It's better, isn't it? Now we're on the right channel. In actual fact, it's receiving fine. Let's just go through that tuning again. I'm just doing it kind of roughly at the moment. Is it that one? I don't know. So we've now got, it's not brilliant, it's 1.7 microvolts for 12 decibel cyanide. We were going to look whether it was on frequency. That's where we got sidetracked. So we'll go back to that. We'll go back onto the frequency counter, and it's 27.7. It's quite a way out, you see. Should be 79125. Heh. It will leave it at that. So now go back on that receive. See if we can just get a little bit better. I'll have to look at the circuits for this. Get the manual out for the Alba H2, or is it the H1? I think there's more than those two for the receive, so I'll just but that is working. It's not good, and it's not good enough to what we are. I'll just see where we are now. That has improved it. Actually, we're at 0.9 of a microvolt, so it is acceptable. See, you don't know whether the termination's correct for that. You know, nice filter, but is that not nicking off some of the sensitivity? I don't know. Anyway, I'll go and print off some service information. Okay, so we've got a copy of the service manual. This, of course, covers then the Harrier as well as the Harvard. It's the same radio. Just want to check how many watts the radio is supposed to be. Transmit is 2 watts. So the fact it's doing 2.5 isn't ideal, to be honest. Let's make sure we're spot on 12 volts. Let's try again. It's 2.5. In view of this having been messed with, I wonder if we can find test point TL1. It's such a poor photocopy. It's virtually illegible, that. At test point 1, I can see test point 1, but I can't see what it connects to. I think it connects to resistor 10 by the looks of it. So we can find resistor 10. There's resistor 9. I think we've got to assume the VCO is correct. I'd like to have really gone through this, but without better, you know, I got this as a photocopy and then we've scanned the photocopy. So, not good. But we will check it works on channel 1 and 40 properly. It's clearly in lock, but I'd like to have gone through it. So what do I need to do? I don't need to adjust T2, 3, 4 and 5 for maximum output. And making sure you bypass the loading coil T1. So back to the circuit. Yes, the jack does that. I think it's a matter of those 4, but I'll just verify. So quite clearly here, 2, 3, 4, 5. 2, 3, 4, 5. Okay, so make sure we're still in picture, press transmit, coil 2, maximum, 3, maximum, 4, maximum, 5, we'll just detune that a little bit for 2. So I'm looking at the current consumption, and at the moment the meter's 690 milliamps. If we take this to 2.5 watts, it's actually still the same. So all we're doing is protecting the PA. Tell you what, we'll make a compromise. We'll put it to 2.2. So that's the transmit power. On low power, the radio is doing 400 milliwatts, which is exactly what it's supposed to do. So we need to look for VR1. Well, this is easy. We press the call button. We don't have to do any whistling and that. So it's effectively got a built-in audio generator because that's a call tone. So VR1 is what we want, and VR1 is this one here. So that's deviation. So if I press both these together, we are going to get. We'll go over to the oscilloscope. Turn the bench light off. Transmit. Tone. Set the. That's interesting. It went off. It's dirty. So now we'll see whether with a whistle, wherever the microphone is. Come here, microphone, where are you? You're under there, are you? Wallow. Wants to just come back a fraction. Wallow. 1, 2. Yeah, that's it. So we've got transmitted audio. What you see on the meter is what you get. So, is that in camera shot? And it's banging across. Making sure that switch is off, which it does. So that is transmit done. So what are we supposed to be getting? So on receive, yeah, it's 1.2 microvolts for 10 dB. You know, is the limit spec. So 1.2 microvolts, so we're on 10 dB. So he's doing, for 10 dB, he's doing 0.75. So although I think that's pretty crap, it isn't. It's, so you've got this limit spec, if you can see that. Ideally, it's supposed to do 0.5 of microvolts, and your limit spec's 1.2. So 0.5 for 10 and we're at 0.75 and your limit's 1.2. So it's in spec, but we'll just make sure that we're absolutely as tuned as we can be. So just 7 and 8. And that's exactly what we were doing. 7. 8. So it's for 10 decibel cyanide is what they want. 7.5. For 12 decibel cyanide, which we're not interested in, 0.85. So it's well in spec. Now they actually get you to set the S meter, and they say 100 microvolts, which is what it is, whatever they say. Yeah, well, at the moment it says 4, so that's something hopefully we can adjust. So that is going to be the only other preset surely down there. Oh no, it's got a squelch preset, and that's where these sets are let down on the squelch. But then it's a handheld, so we're looking for what? What did I say? VR5. So VR5 is the one at the bottom. So if we can also that. Well, that's as high as it'll go. So it's a it's a bit of a lazy needle, you could say. It's reading about 7.5 for where it should be 9. So now that moves us onto the squelch. So let's look at the attenuator controls. We'll switch the squelch to full, and let's see how far we can go with it. Well, that's 1 microvolt and that's it. So it's adjustment VR2, and VR2, no wonder I can't spot it, is under this cable form. So we want this to be as high as it possibly can be. So that's there. No, that's no good at all. It never comes in. That's better. 30 microvolts, the maximum. That's all right actually. So we'll now turn the squelch to minimum. Put the signal generator to standby at 0.3 microvolts. Put the radio to threshold. Switch the signal generator back on. It's straight to in. It's gone off. That's fine. So it's coming in at 0.8 of a microvolt, and it's staying until 0.45. So it's actually one of the better squelches I've seen on this type of radio. So that actually works better than I thought it was going to. So whether or not a bit of the sensitivity is robbed in that filter, I don't want to reverse it, because somebody's at some points paid real good money for that filter. I mean, they were probably about 15 quid or something like that. So it'll be less of a bleed over box. But let's just change channel and see what we get. I'll take it to channel 9. Yeah, it's straight off, so it's not something I would do, but I won't reverse it with it not being one of my sets. If it had been one of my sets, I would have reversed it. So that should be quite a useful set. So I think we're done. Yep, that's it. So all I need to do is put it back in its case. That'll be fun. The next day it's all been through the dishwasher, and just normally when we do, I'll just make sure we've got picture in picture on. Oh, we have, but not where I want it. Normally we do these on a cheap SWR stroke power meter. I'm going to try and do it on the spectrum analyzer just for a different thing, and that is the final coil here. Is it L7, which is the loading coil for the telescopic aerial. So by the way, I put all this back together and there's no sound, and I wonder if the speaker's no good. Remember when you bought it, there was supposed to be no receive, but I didn't have a problem with the receive apart from it being misaligned. So I wonder if the speaker's open circuit. So I'll take it all back out again just for a laugh. So what we need to do is to pull up the telescopic aerial without tickling the camera above me, or poking the camera's eye out. There we go. And then, obviously, without it being plugged into the external aerial, we now need to plug I can do this on low power. Save the PA. So I can also put, we've got a 10 decibel attenuator on this spectrum analyzer. So I'll put this in the vicinity. I'll put channel 20 into the spectrum analyzer. And hopefully when we key up we'll see that. Yeah, that's alright. So now we can twiddle this for maximum peak. There we go. No wonder I couldn't see it. 42. See whether we can just read that on high power a bit easier. $35. Yep. I reckon that's peak. So that's another way to do it. It's actually easier to use a £6.99 SWR meter, but I thought we'd do it that way just for a laugh. So I'll pause the camera once again and we'll see why there's no audio through the speaker. So it's now got around to Saturday. This has been on the bench for about 3 days. This is the Harvard Handheld, and its speaker we got to the conclusion of. So I ordered the nearest I possibly could, because the problem with these is they're only 10mm thick. This is 55mm and it's a mylar cone. And what I was able to do was to get from RS something similar, but it's 50mm, so it's a bit smaller, but I bet you it sounds better than these ever did, because these always sound pretty ropey. So we've still got a mylar cone, but this is clearly a much higher quality item, and it ought to be for about £5. So it's a bit smaller. So we're going to have to use the glue gun. And you know, some years ago I would have really, well, balked at the idea of glue gunning things in. But when we buy products today from China, everything seems to be glue gunned together. So there you go. But that's what we're going to have to do on this occasion. Of course, where are we going to get one of those speakers? And I'd never rated them anyway. So there we go. It's got some long leads, which I think we'll snip off at this point because they're going to interfere with the case going down. So I think we'll actually cut them right off. And I'll just tin those because you never know what solder they've been done with. Luckily this was an in-stock item, so it's came next day, which was yesterday. But I wanted to get on with a Harvard base station today. You've got quite a thick plastic case on this, so that looks considerably smaller in that aperture, but it isn't. So carefully do the glue gun job. I'm supposed to have done this on bench 4, Mr. Chippy's bench, but I brought the glue gun in here. Imagine I'll be in serious trouble if it doesn't go back. Right, let's put that down in the correct position. Now that's going to take some drying. So that was 771-7001 from RS. I looked on AliExpress, I looked on eBay, all kinds of places, you know, but to no avail. I think we'll do what they did and put the cardboard thingy back on, because it looks to me like it can touch. That's 9mm, the old one was 10mm, so we've just gained another millimetre in clearance. So if I find some glue, we'll just pop this cover back on. So I had my first wedding yesterday to play the organ for. And it was strange to see the people in the church all with matching masks to match the bridesmaids' dresses. I think that's set enough for me to start soldering this back together. One of the other problems we've got is that pillar has long since broken, and that's what holds the meter in. So I think what we'll do is we'll put this back together. I'll put a dab of glue on there in the hope that it holds better than it has done in the past, shall we say. So let's look at this wiring. How have they got this wired? I want to be absolutely certain that we're getting this right. So the two wires that come off the radio, we've got the grey one and the black one. The black's obviously expected to be ground. So they're picking the ground up from the speaker, and that should be the outer. But are they switching the outer? So I've got continuity on... No, I haven't. That was me slipping. We've got continuity on there. And not on there. So that looks to me like we've got the earth. Double check. It's confusing because the positive is a grey wire, and then they've used a grey wire. And then they used the red one for the positive. So yeah, okay. So the positive one goes there, which is correct. And negative one doesn't go there. Good. So now we'll put the positive wire. This video is going to be about an hour and a half by the time I've done all this. Negative wants to go there. And then the socket picks up its negative from there as well. You know, it doesn't have to do that. Let's pick the negative up from the printed circuit board. Tell you what, we'll pick it up from there. That seems a much more sensible way to do it. We don't want to be soldering two wires onto the speaker. A nice bit of pad there to put that. There we go. So I'll put the meter away in the hope. We'd better turn on the radio and see if we've got audio. We've got audio. And then we'll see if we've got audio through this socket. And it cuts out the internal speaker, which is correct. Right, I'll bravely start putting this together. Okay, so here we are on its own speaker. Let's see whether we can hear anything. One on a Roger. Thank you very much for that. I'm at Ancaster. Cheers. Yeah, breaker at Holdingham Roundabout. You got the Tango 21, and I'm at Ancaster. Ancaster, over. Thank you. Well, not only any breaker, but a lady breaker, and 7.7 miles at Holdingham Roundabout. Well, that works. And I'll tell you what, it does sound better than these ever did with that RS speaker in it. Right, well there we go. Having to kind of run it on the power supply. So we'll do an on-the-air test later. This won't be a field test where we put batteries in it and go out. We've already covered this set on a field test, I'm sure. And we don't do that with customer sets. I'll put it on the aerial, we'll sit here and we'll let Mr. Chippy drive away as usual, but I've just proved that it works 7.7 miles. So thank you for watching the rather involved Harvard H410T, which now works again.